All right. Our topic for this week one, is dimensions, quantities, and units. Dimensions, quantities, and units. Let's start up. What's a physical quantity? What is a physical quantity? It is a description of matter that contains both a numerical value and the unit in which it was measured. A physical quantity is a description of matter, or you could say it's a measurement of matter that contains both a numerical value and the unit in which it was measured. Right? Physical quantities are represented by letters or symbols and could either be fundamental or derived quantities. Fundamental quantities. Remember we said a physical quantity could either be fundamental or a derived quantity. Let's start with fundamental quantities. What are fundamental quantities? These are the basic quantities, just like foundational. Just think of foundation. The basic quantities that are not dependent upon other quantities. So they are like the building blocks of all other quantities. They are basic. They are not dependent upon other quantities. In fact, other quantities are dependent upon fundamental quantities. So their units are called fundamental units. Now, derived quantities, these ones are obtained by some combination of fundamental quantities and units. So look at the derived quantity we have. Let's look at this derived quantity. We call it density. Call it density. That's the symbol rho. It's like a slanted P. Density is the derived quantity. Why? Because look at its formula. Formula is mass over volume. Or look at the final unit of density, kilogram per meter cube. The density is derived because it's made up of mass, which is a fundamental quantity, and length, which is also a fundamental quantity. And volume is given by length times length times length. Remember? So mass over length cube, because length times length times length is L cube. That's mass over, that's kilogram per meter cube, and that's a derived unit. Let's look at dimensions of physical quantities. Dimensions of physical quantities. So we have mass, length, and time. These are the three main basic dimensions of physical quantities. Remember, we have, these are all fundamental quantities, by the way. The dimensions, we can describe quantities in terms of the dimensions using these three basic quantities of mass, length, and time. We can use the method of dimensional analysis to verify whether a physical equation is correct or not. We can use the method of dimensional analysis to verify whether a physical equation is correct or not. I'll do an example. Quickly, let's look at the dimension of density. Dimensions of density. To be able to break down the density into its dimensions, you need to know either the formula, which is mass over volume, or its unit, derived unit, kilogram per meter cube. From kilogram, you can see that kilogram is a unit for mass, and meter cube is a unit for volume. L times L times L. So the dimension for density is mass over L cube, or mL raised to the power -3. Look at the dimensions of force. So you can analyze the dimension, you can analyze force into its dimensions using either its unit, its derived unit, kilogram meter per second squared, or its formula, force equals mass times acceleration. Since we know that unit of mass is kilogram, unit of acceleration is meter per second squared, because ma means mass times acceleration. So just break it down. Kilogram is mass, meters is length, and that's all over time squared, t squared, s for second, right? So t squared. So break that gives you mL t raised to the power -2. That's the dimension of force.